Welcome to Advanced Cloud Armor. Welcome to the channel. Please consider subscribing. I produce videos daily, covering a wide variety of cloud topics, with a focus on networking. Hit the bell icon to get notified. Today we're covering Google Cloud's advanced security capabilities with Cloud Armor. This isn't just basic DDoS protection. We're talking about enterprise-grade, AI-powered security that can adapt and learn from threats in real time. Think of Cloud Armor as your application's bodyguard that never sleeps. It sits at the edge of Google's global network, analyzing every single request before it reaches your servers. What makes it truly special are its 4 key pillars that we'll explore today. First, adaptive protection uses machine learning to automatically detect and respond to new attack patterns. Second, sophisticated rate limiting that goes far beyond simple request counts. Third, bot management that can distinguish between helpful search engine crawlers and malicious scrapers. And finally, Google's massive threat intelligence network that shares attack data across the entire platform. By the end of this presentation, you'll know how to configure these advanced features to create a multi-layered security strategy that protects your applications while maintaining performance for legitimate users. The 4 pillars of advanced security. Let me walk you through what makes Cloud Armor so powerful. These 4 pillars work together like a well-orchestrated security team, each handling different aspects of threat protection. Adaptive protection is like having a security expert who learns your traffic patterns and automatically creates new rules when something suspicious happens. It uses the same machine learning technology that powers Google's other services to identify threats that traditional signature-based systems would miss. Rate limiting isn't just about counting requests, it's about understanding context. You can set different limits for different user types, geographic regions, or even specific API endpoints. It's smart enough to know that a power user should get higher limits than an anonymous visitor. Bot management is crucial in today's web where legitimate bots like search engines need access, but malicious scrapers and automated attacks need to be stopped. Cloud Armor can challenge suspicious traffic with JavaScript tests or CAPTCHAs while allowing known good bots through. Finally, threat intelligence connects your application to Google's global view of the threat landscape. When Google detects a new malware command and control server anywhere in the world, your application automatically starts blocking traffic from it. Adaptive protection deep dive. Now let's get into the technical details of adaptive protection. This is where Cloud Armor really shines with its artificial intelligence capabilities. The system starts with a learning phase where it observes your normal traffic patterns for about 7 to 14 days. During this time, it's building a baseline of what legitimate traffic looks like for your specific application. Every request is analyzed for patterns like timing, request structure, user behavior, and more. Once the baseline is established, the ML engine continuously compares incoming traffic against these learned patterns. When it detects anomalies that suggest an attack, it can automatically generate new security rules. The confidence threshold determines how certain the system needs to be before taking action. What's really impressive is the feedback loop. As the system blocks attacks and observes the results, it refines its understanding of threats. False positives help it learn what legitimate edge cases look like, while successful blocks reinforce its threat detection capabilities. The auto-deploy feature can automatically implement these ML-generated rules when confidence levels are high enough. This means your application can defend against zero-day attacks without any human intervention. Configuring adaptive protection. Let me show you how to actually configure adaptive protection in practice. The key is to start conservatively and gradually increase automation as you gain confidence in the system. First, we create a security policy and enable basic adaptive protection. The load threshold of 0.8 means the system needs to see a significant increase in traffic before considering it potentially malicious. The auto-deploy threshold of 0.9 is even higher. This ensures only high-confidence rules get automatically implemented. The confidence threshold of 0.6 means the ML system needs to be at least 60% confident that traffic is malicious before suggesting a rule. The impacted baseline threshold ensures that any auto-generated rule will not affect more than 10% of your normal traffic patterns. Notice the expiration time of 7200 seconds, which is 2 hours, for auto-deployed rules. This is a safety mechanism. If an automatically created rule starts blocking legitimate traffic, it will expire automatically, giving you time to review and adjust. I always recommend starting with learning mode only, then gradually enabling auto-deploy as you become comfortable with the system's behavior. Monitor the suggested rules carefully during the first few weeks to understand how the system interprets your traffic. Adaptive protection implementation steps. Here is the proven approach I recommend for implementing adaptive protection in production environments. This step-by-step process minimizes risk while maximizing security benefits. The learning phase is critical. Resist the temptation to rush this. During these 7 to 14 days, the system is building its understanding of your application's unique traffic patterns. Run your normal operations, including any batch jobs, scheduled tasks, or periodic high-traffic events. The more complete the baseline, the better the protection. During the monitoring phase, you will start seeing suggested rules in the console. Review these carefully with your team. Look for patterns in what the system is flagging. Are there legitimate user behaviors that look suspicious to the ML engine? Document these as potential false positives. Gradual deployment means slowly increasing the auto-deploy thresholds. Start with very high confidence requirements and gradually lower them as you build trust in the system. Monitor your application's error rates and user feedback during this phase. Full protection mode is where you will eventually want to be, but only after you have validated the system's behavior with your specific traffic patterns. Even then, always maintain logging and alerting to catch any unexpected behavior. Rate limiting strategy overview. Now let's move into rate limiting, which is your defense against both malicious attacks and legitimate but overwhelming traffic. This isn't just about counting requests. It's about understanding context and applying intelligent traffic control. Think of rate limiting as having different speed limits for different types of roads. A residential street has a 25 mph limit, a highway allows 70 mph, and a school zone drops to 15 mph. Similarly, your API endpoints need different rate limits based on their purpose and the user making the request. CloudArmor's rate limiting goes far beyond simple IP-based counting. You can set different limits based on user authentication status, geographic location, specific API endpoints, or even custom headers. The system supports progressive enforcement. Maybe the first violation gets a warning, the second gets throttled, and the third gets temporarily banned. What makes this really powerful is the ability to combine multiple enforcement keys. You might have a global rate limit per IP, but also a per-user limit for authenticated requests, and special limits for specific high-cost operations like file uploads or database queries. The decision flow I'm showing here demonstrates how CloudArmor evaluates multiple rate limit conditions in sequence, allowing for sophisticated traffic management policies. Basic rate limiting configuration. Let me walk you through the fundamental rate limiting configurations. The key is to start with reasonable defaults and then refine based on your actual traffic patterns. The first example shows a basic IP-based rate limit of 100 requests per minute. Notice the rate-based ban action. This doesn't just drop requests, it temporarily bans the IP for 5 minutes after the threshold is exceeded. This is much more effective than simple throttling because it prevents attackers from just backing off slightly and continuing their assault. The enforce on key parameter is crucial here. Setting it to IP means each IP address gets its own independent counter. The conform action is allow for requests within the limit, and exceed action is deny 429, which returns an HTTP 429 status code, the standard too many requests response. What I love about this approach is that legitimate users who occasionally burst over the limit get a clear error message they can understand, while persistent attackers get banned entirely. The ban duration of 300 seconds, 5 minutes, is long enough to deter automated attacks but short enough that a legitimate user who made a mistake isn't locked out for too long. Always start with generous limits and tighten them based on your monitoring data. It's much easier to lower limits than to deal with angry users who can't access your application. User-based rate limiting. Now, this is where rate limiting gets really sophisticated. Instead of treating all traffic the same, we can apply different limits based on who the user is and how they're authenticated. The first rule here looks for an authorization header and applies a much higher limit, 1,000 requests per minute instead of 100. This makes perfect sense. Authenticated users have gone through your registration process, they're identifiable, and they probably have legitimate reasons for higher usage. The enforce on key is set to HTTP_header with the header name authorization. This means each unique authorization token gets its own rate limit counter. So, if you have 1,000 authenticated users, each one gets their own 1,000 requests per minute allowance. The second example shows a custom user ID header approach. Maybe your application sets an X_user_ID header after authentication. This gives you even more granular control. You could have different rate limits for different user tiers, premium customers, or admin users. Notice the different ban duration. 600 seconds, or 10 minutes, for authenticated users versus 300 seconds for anonymous traffic. Since these users are identifiable, a longer ban provides better protection against compromised accounts while still being reasonable for legitimate users who hit the limit accidentally. Globe geographic and path-specific limiting. Geographic rate limiting is where CloudArmor's global intelligence really shines. Not all traffic sources are created equal, and your rate limiting should reflect that reality. The first rule gives higher rate limits to trusted regions like the US and Canada, 200 requests per minute instead of the default 100. These are typically lower risk regions with better internet infrastructure and law enforcement cooperation. The shorter ban duration of 180 seconds reflects this lower risk assessment. The second rule takes the opposite approach for high-risk regions. Countries like China, Russia, Iran, and North Korea get much stricter limits, only 20 requests per minute, and much longer ban durations of 900 seconds, or 15 minutes. This isn't about discrimination. It's about recognizing that these regions are statistically more likely to be sources of malicious traffic. The path-specific rules show how to protect your most sensitive endpoints. File upload endpoints get very restrictive limits because they're resource-intensive and attractive targets for abuse. Login endpoints get special protection against brute force attacks. Only 5 attempts per 5 minutes, with a 30-minute ban. The key is layering these rules thoughtfully. A user might pass the geographic check but still get blocked on the login endpoint if they're attempting a brute force attack. Advanced rate limiting scenarios. Let's look at some real-world scenarios that demonstrate the power of CloudArmor's flexible rate limiting system. API endpoint protection is crucial for modern applications. Different endpoints have different resource costs and security implications. A simple GET request to fetch user profile data might handle hundreds of requests per minute, but a file upload endpoint might only handle a few dozen. Search functionality often gets abused by scrapers trying to enumerate your entire database. The rate limit here protects against both malicious scraping and legitimate users who might accidentally trigger automated searches. The moderate ban duration gives attackers time to reconsider while not overly punishing curious users. The table I'm showing provides recommended starting points for different types of endpoints, but remember, these should be adjusted based on your specific application requirements and traffic patterns. A high-volume e-commerce site will need much higher limits than a small business application. Notice how the ban durations scale with the severity of the potential abuse. General traffic violations get short timeouts, but login abuse gets much longer bans because brute force attacks are inherently malicious. The key to successful rate limiting is monitoring and iteration. Start with conservative limits, monitor your traffic patterns and error rates, then adjust accordingly. Your users will thank you for smooth performance, and your servers will thank you for protection against abuse. Bot Management Overview. Now we're entering one of the most challenging areas of web security: distinguishing between good bots and bad bots. This isn't just about blocking everything that looks automated. That would break search engine indexing, monitoring tools, and legitimate API integrations. Think of bot management like airport security. You don't want to stop every traveler, but you need sophisticated systems to identify and handle potential threats. Good bots are like passengers with TSA pre-check. They get expedited processing. Suspicious traffic gets additional screening. And clearly malicious bots get denied entry entirely. CloudArmor's bot management uses multiple detection techniques: behavioral analysis, JavaScript challenges, user agent analysis, and even advanced fingerprinting. The sequence diagram I'm showing demonstrates how these work together to make intelligent decisions about each request. The key insight is that legitimate users and good bots behave differently from malicious automation. Humans have inconsistent timing, interact with JavaScript, and follow natural browsing patterns. Good bots identify themselves clearly and follow robots.txt rules. Bad bots try to hide their nature and often exhibit suspicious patterns like perfect timing or missing browser headers. CloudArmor can challenge suspicious traffic with JavaScript tests or captchas without impacting the user experience for clearly legitimate traffic. Bot detection and configuration. Let me show you how to configure bot management rules that balance security with usability. The key is starting with known patterns and gradually expanding your coverage. The first rule looks for suspicious user agents that contain bot-like keywords but aren't from known good sources. This catches many amateur scraping attempts that don't bother to hide their user agent strings. The redirect action sends them to a reCAPTCHA challenge rather than blocking outright. This gives legitimate tools a chance to prove they're operated by humans. The second rule is more aggressive: blocking user agents that are known to be malicious. These are tools that are almost never used for legitimate purposes. There's no point in challenging these. They should be blocked immediately. The third rule catches requests that are missing common browser headers. Legitimate browsers always send accept and accept language headers, but many automated tools forget to include them. This is a subtle indicator that often catches sophisticated bots that have good user agent strings but miss other details. Notice the integration with reCAPTCHA Enterprise. This isn't just a simple challenge. Google's reCAPTCHA uses advanced risk analysis to determine whether challenges are even necessary, making the user experience much smoother while maintaining security. Behavioral analysis for bot detection. This is where bot management gets really sophisticated. Instead of just looking at individual requests, we're analyzing patterns of behavior that distinguish humans from automation. The rapid request detection rule is brilliant because it combines rate limiting with behavioral analysis. Humans simply can't make 30 requests in 10 seconds consistently, but bots often do. Instead of just blocking these requests, we challenge them with reCAPTCHA. If it's a legitimate user with a flaky network connection or aggressive browser prefetching, they can prove they're human. If it's a bot, it fails the challenge. The cookie-less API request rule addresses a common bot behavior. Legitimate web applications typically establish sessions with cookies before making API calls. Bots often skip this step and go straight to the API endpoints. By challenging cookie-less API requests, we catch many automated scrapers while allowing legitimate API integrations that properly handle the challenge flow. These behavioral rules are powerful because they're harder for attackers to circumvent. They can change their user agent strings easily, but changing their fundamental request patterns is much more difficult. The key is to use these rules in combination. A request might pass the user agent check but fail the behavioral analysis, or vice versa. Layering these detections gives you much better coverage than any single approach. Advanced bot protection strategies. Now let's look at some advanced techniques for dealing with sophisticated bots that try to evade basic detection methods. Headless browser detection is crucial in today's threat landscape. Tools like Puppeteer and Selenium are commonly used for legitimate testing, but they are also favorite tools of advanced scrapers. The user agent strings often give them away, so we can block the most obvious cases immediately. The automation tool detection rule catches browsers being driven by testing frameworks. This is a judgment call. You might want to allow these in your development environment but block them in production. The challenge action gives you flexibility to handle edge cases. Geographic bot filtering adds another layer of intelligence. A bot claiming to be Googlebot but coming from a suspicious country is almost certainly fake. Legitimate search engine bots come from known IP ranges that match their claimed identity. The allow listing approach I mentioned in the warning is critical. You will want to explicitly allow known good bots like search engines, monitoring services, and legitimate API clients. These should be identified by IP ranges and proper authentication, not just user agent strings. Always start with challenge actions rather than outright blocks. This gives you data on false positive rates and lets you refine your rules before implementing harsher enforcement. Bot management best practices. Let me share the lessons I've learned from implementing bot management in production environments. These practices will save you from common pitfalls and help you build a robust defense. The allow list first approach is absolutely critical. Before you start blocking bots, make sure you've explicitly allowed all the legitimate automated traffic you want to keep. This includes search engine crawlers, uptime monitors, legitimate API clients, and any internal automation tools. Monitoring and iteration cannot be overstated. Bot behavior evolves constantly, and your rules need to evolve with them. Set up comprehensive logging and review it regularly. Look for patterns in blocked requests. Are you catching new attack methods, or are you accidentally blocking legitimate users? The graduated response strategy works much better than binary allow/block decisions. Start with challenges for suspicious traffic. Escalate to temporary blocks for confirmed bots, and reserve permanent blocks for clearly malicious sources. Challenge selection matters too. JavaScript challenges work well for simple bots, but advanced scrapers can execute JavaScript. CAPTCHAs are more effective but impact user experience. reCAPTCHA Enterprise offers the best balance, often requiring no user interaction while still blocking bots. Remember that bot management is an arms race. As your defenses improve, attackers adapt their techniques. Stay informed about new bot technologies and adjust your strategy accordingly. The goal isn't perfect security. It's making attacks expensive enough that attackers move on to easier targets. Google Threat Intelligence Overview. Now we're going to explore one of CloudArmor's most powerful features: integration with Google's Global Threat Intelligence Network. This is where your application gets connected to the same threat data that protects Google's own services. Think of threat intelligence as having a global neighborhood watch that spans the entire internet. When Google detects a new malware command and control server in one part of the world, or identifies a new attack pattern being used against other applications, this information gets shared across the entire CloudArmor network. The architecture diagram shows how this works. Google's threat intelligence system continuously collects indicators of compromise from across their global infrastructure. This includes malicious IP addresses, attack signatures, compromised domains, and behavioral patterns that indicate threats. What makes this incredibly powerful is the scale. Google processes billions of requests daily and can spot emerging threats faster than any individual organization could. When they identify a new threat, it gets added to threat feeds that are automatically consumed by CloudArmor policies. Your application benefits from this collective intelligence without any additional configuration. It's like having a team of security researchers working 24/7 to protect your specific application, even though they're protecting the entire internet. Threat intelligence feeds and configuration. Let me show you how to actually leverage Google's threat intelligence feeds in your security policies. These pre-configured expressions make it incredibly easy to block known threats without having to research and maintain threat lists yourself. The first category focuses on IP reputation. The Tor exit node feed blocks traffic from known Tor endpoints. This might be appropriate for some applications, but consider your use case carefully. Some legitimate users rely on Tor for privacy. The malware CNC feed is much more universally applicable. These are IP addresses that Google has identified as hosting malware command and control infrastructure. There's almost no legitimate reason for normal users to be connecting from these addresses, so blocking them is usually safe. The scanning sources feed blocks IPs that are known to be conducting network reconnaissance or vulnerability scanning. This is great for reducing noise in your logs and preventing automated attacks from getting started. What I love about these feeds is that they're continuously updated in real time. You don't have to worry about maintaining threat lists or updating signatures. Google's security team does the heavy lifting, and your application automatically benefits from their research. The table shows update frequencies. Some feeds update in real time as new threats are discovered, while others have daily or hourly updates for more stable threat categories. Attack pattern detection and custom rules. Beyond IP-based threats, Google's threat intelligence also includes sophisticated attack pattern detection. These are behavioral signatures that identify specific attack techniques, regardless of where they are coming from. The CVE Canary feed is particularly impressive. This detects active exploitation attempts for known vulnerabilities. When a new CVE is published and attackers start scanning for vulnerable systems, Google can detect these patterns and automatically protect CloudArmor users. Protocol-level attacks cover fundamental weaknesses in how applications handle HTTP requests. These might include malformed headers, unusual request structures, or attempts to exploit parsing vulnerabilities in web servers. Session fixation attacks try to hijack user sessions by manipulating session identifiers. This is a classic web application attack that has been around for years, but still catches many applications off guard. The custom threat intelligence rules show how you can extend Google's feeds with your own threat intelligence. Maybe you have identified specific malicious domains in your industry, or you want to block requests from known bad referrers. The cryptocurrency mining detection is a great example of evolving threats. As browser-based mining became popular for malicious actors, Google added detection capabilities for these patterns. Comprehensive security policy integration. Now let's bring everything together. This slide shows how to create a comprehensive security policy that combines all the advanced CloudArmor features we've discussed: adaptive protection, rate limiting, bot management, and threat intelligence. The key insight here is layered security. We are not relying on any single protection mechanism, but instead creating multiple lines of defense that work together. Think of it like a medieval castle. You have the moat, the outer walls, the guard towers, and the inner keep. Each layer provides protection, and attackers have to defeat all of them to succeed. Layer 1 uses threat intelligence to block known bad actors immediately. These are the threats we are most confident about: malware CNC servers, known attack sources, active CVE exploitation attempts. There is no reason to waste resources analyzing traffic from these sources. Layer 2 applies geographic restrictions based on your application's requirements. This might block entire countries that do not represent legitimate user bases for your application. Layer 3 handles bot management, distinguishing between legitimate automation and malicious bots. This protects against scrapers, fake account creation, and other automated abuse. Layer 4 implements rate limiting to prevent both malicious attacks and legitimate traffic overload. This ensures your application remains available even under stress. Finally, Layer 5 provides application-specific protections against common web application attacks like SQL injection, XSS, and other OWASP top 10 vulnerabilities. Monitoring, optimization, and production success. The final piece of the puzzle is monitoring and continuous optimization. Security isn't a set it and forget it solution. It requires ongoing attention and refinement. The monitoring commands I'm showing help you understand how your security policies are performing. You can see which rules are triggering most frequently, identify potential false positives, and understand attack patterns targeting your application. The policy optimization section demonstrates the iterative nature of security configuration. You'll start with conservative settings and gradually tune them based on real traffic patterns. This might mean adjusting rate limits, refining bot detection rules, or adding new threat intelligence feeds. The backup and restore capabilities are crucial for production environments. Security policies often evolve rapidly, and you need the ability to quickly roll back changes if something goes wrong. The success metrics at the bottom represent what you can achieve with properly configured CloudArmor. 99.9% attack mitigation with less than 1 millisecond additional latency means your users get both security and performance. Remember, the goal isn't perfect security. It's making attacks expensive enough that attackers move on to easier targets. By implementing these layered defenses and continuously monitoring their effectiveness, you create a strong security posture that protects your application while maintaining excellent user experience. The key to long-term success is treating security as an ongoing process, not a one-time setup. Stay informed about new threats, regularly review your security logs, and don't hesitate to adjust your policies as your application and threat landscape evolve. Thank you for your attendance. Please hit the subscribe and like button. I would greatly appreciate it.